Steel oil drums are some of the most rugged and widely used industrial containers on the planet, trusted to safely hold everything from crude oil and chemicals to food products and hazardous materials. Yet behind every blue or black barrel is a fast-moving factory process that transforms flat sheets of steel into sealed, pressure-tested containers built to survive rough handling, stacking, and global transport. What looks like a simple cylindrical drum is actually the result of precision forming, automated welding, high-force rolling, and strict quality control designed to meet international safety standards. And today on the How Factory, we're going inside modern drum manufacturing plants to see exactly how steel oil drums are made, from flat metal to heavy-duty barrels used worldwide. The steel drum has a long industrial history. In the early days of oil and chemical transport, liquids were moved in wooden barrels, which leaked, warped, and failed under heavy use. As steel production became more affordable in the early 20th century, manufacturers began experimenting with metal containers that could be mass-produced, sealed tightly, and reused many times. The steel drum quickly became the global standard because it was strong, stackable, fire-resistant, and compatible with mechanized handling. Today, hundreds of millions of steel drums are produced every year, all built to precise dimensions so they can move seamlessly through global logistics systems. The process begins with raw steel arriving at the factory in large coils or flat sheets. This steel is typically low-carbon steel, chosen for its strength, formability, and weldability. Before anything is formed, the steel is inspected for thickness, surface quality, and consistency. Even small variations can cause problems later during rolling or welding. Once approved, the steel is uncoiled and fed into cutting lines. For the drum body, steel sheets are cut into rectangular blanks, sized precisely to form the cylindrical shell. Automated shearing machines slice the steel at high speed, producing clean, straight edges. These blanks will become the sidewalls of the drum. At the same time, other steel sheets are prepared for the top and bottom ends of the drum, which require different forming processes. The body blank now moves into rolling machines. These machines bend the flat steel into a curved shape, gradually forming a perfect cylinder. The edges of the steel meet, creating a vertical seam running the full height of the drum. This seam is one of the most critical parts of the entire container because it must be strong, leak-proof, and consistent from top to bottom. To seal the seam, manufacturers use high-speed welding systems. Many plants use electric resistance welding, where pressure and electric current fuse the steel edges together into a continuous weld. The process happens in seconds, producing a smooth, strong joint. Some drums may use laser or arc welding, depending on design and application. Sensors monitor weld quality in real time, checking alignment, temperature, and continuity. A poor seam would compromise the entire drum, so defective shells are rejected immediately. Once welded, the cylindrical shell is trimmed to exact height. Cutting machines square the top and bottom edges to ensure the drum will seal properly when ends are attached. The shell then moves to a forming station where it begins to look like a real drum. One of the most recognizable features of a steel oil drum is the set of reinforcing ribs around its body. These ribs, also called rolling hoops or beads, are not decorative, they are structural. The shell is fed through bead-forming machines that press circular ribs into the steel wall. These ribs dramatically increase strength, allowing the drum to withstand internal pressure, stacking loads, and impacts during handling. The number and placement of ribs depend on drum size and standards. With the body formed, attention turns to the top and bottom ends. Drum ends start as flat circular steel blanks punched from sheet steel. These blanks are then shaped using hydraulic presses that form shallow domes or profiles. The bottom end is typically solid, while the top end may include openings depending on the drum type. Closed-head drums, commonly used for liquids, have a solid top with two threaded openings, one large bung and one small vent bung. Open-head drums, used for solids or thick materials, have a removable lid. For closed-head drums, punching machines create precise holes in the top end, and threaded fittings are installed or formed. These threads must meet strict standards, so caps and bungs seal reliably across different manufacturers. Now comes assembly. The formed top and bottom ends are attached to the cylindrical shell using a process called seaming or crimping. The drum shell and end are brought together, and powerful rollers fold the steel edges together into a tight mechanical lock. This double seam creates a strong, leak-resistant joint without requiring welding. The seaming process is carefully controlled. Too loose and it leaks, too tight and the metal cracks. Automated seamers monitor force and geometry constantly. Once both ends are attached, the drum is structurally complete. But before it can be used, it must be cleaned and treated. Freshly formed drums may have oil, metal dust, or residue from manufacturing. They pass through washing or cleaning systems that remove contaminants. Some drums receive internal coatings, especially if they will hold chemicals, food products, or corrosive materials. Internal coatings are applied by spraying or rolling specialized linings inside the drum. These linings prevent chemical reactions between the steel and the contents, protecting both the product and the drum. After coating, drums are baked in curing ovens to harden the lining and ensure it bonds permanently to the steel. Next comes external finishing. Steel drums are typically painted to protect against corrosion and to identify contents. Painting lines apply primer and top coat using spray systems or electrostatic coating. Blue is common for oil drums, but colors vary depending on customer requirements and industry standards. Paint thickness and coverage are monitored closely because drums may be stored outdoors for long periods. Once painted, drums move through drying ovens where heat cures the coating. After cooling, logos, hazard markings, and identification codes may be printed or stenciled onto the drum body. These markings are critical for safety and traceability in chemical and oil industries. Quality control is one of the most important stages in drum manufacturing. Finished drums undergo multiple tests. Visual inspections check seams, paint quality, and shape. Dimensional checks ensure the drum meets standardized sizes so it fits pallets, racks, and handling equipment. Leak testing is especially critical. Drums may be pressurized with air and submerged in water, or tested using pressure sensors that detect leaks without immersion. Some drums are tested for stacking strength by applying heavy loads to ensure they won't collapse when stacked in warehouses. Others undergo drop tests, where filled or partially filled drums are dropped from specific heights to simulate accidents during transport. These tests ensure drums can survive real-world abuse without failing. Only drums that pass all tests are approved for shipment. Approved drums are palletized or stacked and wrapped for transport. Because steel drums are designed to be reused, many are shipped to filling facilities empty, then returned after use for cleaning and reconditioning. Reconditioned drums are cleaned, inspected, and reused multiple times, making them an important part of industrial recycling systems. Sustainability plays a major role in modern drum production. Steel is one of the most recyclable materials on Earth, and steel drums often contain recycled content. At the end of their life, drums can be melted down and turned into new steel products with minimal loss of quality. Many manufacturers also focus on producing thinner, lighter drums without sacrificing strength, reducing material use and transport emissions. What makes steel oil drum manufacturing remarkable is how much engineering goes into something that appears simple. A drum must seal perfectly, resist corrosion, survive impacts, hold pressure, stack safely, and fit into a global system of pumps, racks, forklifts, and transport vehicles. Every curve, rib, and seam exists for a reason. From flat steel sheets uncoiled on factory floors to cylindrical shells welded and reinforced, from precision-formed ends to sealed seams, from protective coatings to rigorous pressure testing, the journey of a steel oil drum is a fast, precise industrial process built for reliability above all else. And that is exactly how steel oil drums are cut, rolled, welded, reinforced, sealed, coated, tested, and shipped, transforming flat metal into heavy-duty barrels that safely move liquids and materials around the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories and machines behind everyday industrial products.